So I wanted to follow up on one of the things that we were talking about kind of right at the end of the last video, which actually sort of ended here, right? We ended up sort of doing a quick little graph of this -2, 3 pi over 2 polar point, this polar coordinate, because 3 pi over 2 as an angle, right, should tell us that we're kind of heading straight down, kind of due south. But because the radius here was negative, we actually headed the opposite direction, due north. And that kind of opens up this idea that in polar coordinates, you have a number of different ways that you can actually sort of express a particular point. So I just want to talk for a few minutes about what you would do to kind of get some of these different versions in the homework. They actually ask you to sort of write the polar coordinates in multiple ways in some of the problems. So I just want to take a few minutes and just like make sure we've seen that. This is kind of like a polar coordinate system where rather than, and in some sense you can get, our regular kind of rectangular coordinate system if you think of these as kind of 1, 2, 3, 4. But what I'm drawing in here are sort of full radiuses. So this is kind of radius 1, 2, 3, 4, and then of course going out. So you get this kind of bullseye type thing. Not perfect, of course, because I drew it by hand, nevertheless. So let's just kind of pop a point on here, and then let's talk about a couple different ways that we could draw it. So maybe we've got our point here. I'm just going to kind of label this point A. And so first and foremost, what I usually do polar coordinates, even though it's sort of listed as radius and then the angle, I actually kind of usually do the angle first in my head when I'm graphing it, and then the radius. So this angle here, it looks like it's about the, what would be the 45-degree angle in this sort of quadrant 2. So what's that in radians? 3 pi over 4, right? So I would say the angle here is 3 pi over 4. And then if we look to see our radius, right, how many notches out did we go? 1, 2, 3. Looks like the radius here is 3. So the most like obvious and maybe natural way to kind of define that point would be to say, okay, so this is sort of +3 on the radius, and the angle is 3 pi over 4. Not a big deal, right? We can get there no problem. So let's talk through a couple different variations. One thing you could do would be to do this negative radius kind of move. So A would also be right. So what if this was -3 instead? So what's the connection here? Well, so if this is -3, that means you're actually moving backwards into quadrant 2 to get to point A. So rather than like be facing 3 pi over 4, you're actually facing, right, kind of 180 degrees the opposite direction down here at the sort of pi over 4 angle in quadrant 4, right? So you're facing down here, and then you're moving backwards into quadrant 2. So what would the angle be down here? Well, if we're moving, if it's sort of a 180 flip, that would be, right, in radians would be like adding 1 pi. And of course, we probably know already in quadrant 4, this 45-degree angle, the pi over 4 angle would be 7 pi over 4. So 3 pi over 4 plus pi would get us to 7 pi over 4. So you can kind of add pi to the angle and then flip the sign on the radius from positive to negative, or vice versa if you started with a negative, and you're going to get a different version of the same point, right? So if you want to flip your radius from positive to negative, you can do that. You just have to kind of add, or in theory subtract. I mean, you could think of this as negative pi over 4 if you wanted to sort of think of it as getting down to quadrant 4 in the negative way. That would work too. You could also do like coterminal angle stuff. So maybe we're doing our positive radius, but maybe instead of 3 pi over 4, let's do like a negative version. So we're maybe rotating clockwise instead of counterclockwise. So that would be, right, kind of pi over 2, pi, plus another pi over 4. So that would be a -5 pi over 4. And then the radius is 3, right, to kind of get us to the same point. So that's another way to go. You could also do coterminal by just like adding 2 pi. This would be to get the negative when you're kind of subtracting 2 pi. If we added a full rotation around, you would get, right, another version of this. So you'd have kind of radius 3, and then you would do right. So plus 2 pi, so that would be plus like 8 over 4. So then that's going to be something like 11 pi over 4. Right? So a number of different ways to sort of take a point and then just sort of like rewrite it. That was kind of just one point picked at random. You could do this for any point you wanted to, and then go from there. Just as a bonus, maybe let's do a quick conversion on this point as well. So this is in polar coordinates. Let's also convert to rectangular, just to have another one of those in the bank. So this was, let's do, right, 3 and 3 pi over 4 is my radius and my theta. So my x value, right, is going to be the radius times cosine. So 3 times cosine 3 pi over 4. That's going to be 3 times, so negative root 2 over 2. So negative 3 root 2 over 2. And then the sine value would be 3 times, I'm sorry, the y value would be 3 times the sine value. So that would be 3 times, sine in quadrant 2 is positive, so positive root 2 over 2. So 3 root 2 over 2. So as an xy coordinate, this would be negative 3 root 2 over 2, and then positive 3 root 2 over 2. Right. Those conversions go pretty fast. Once you're kind of used to what to expect, the conversions themselves go relatively quickly. We'll do one last video here. I'm going to cut this one. I just want to talk briefly in the next video about polar equations. So doing, you know, right, in these polar coordinates, you can also sort of get polar equations. So equations in terms of the radius and the angle rather than in terms of x and y.